Welcome back at C Squared. In this lesson, we will talk about rhombus. And rhombus, you see here, it says is a parallelogram with all four sides congruent. So let's see a picture here. This is the picture of a rhombus, and you notice it is a parallelogram. We notice these two sides are parallel, and these two sides are parallel. But also we notice all sides are congruent. And you see these statements I just mentioned right here. The two sides parallel and all sides are congruent. Because rhombi are special parallelograms, rhombi have the same property as parallelograms. However, there are some other properties that you're going to see it here. So this one, the first property, yeah, it comes from the fact that it's a parallelogram, 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 parallelograms. And from here, yeah, we have the rhombus. All sides are congruent. Diagonals are perpendicular, so that works only for rhombus. And diagonal bisect the angle of the rhombus. So the last three, these three, goes only with this shape, rhombus. And like I said, the other one are specific to parallelograms. Okay, so you are not wrong if you call a rhombus a parallelogram. However, be careful, not all parallelograms are rhombi. So now let's see how we solve some problem involving rhombus. Find the measure of the number angles in each rhombus, in this rhombus in fact. And in here we have beside the angles, we need to find some sides. We need to find how long this DC is. And we notice here, this is 26. And because this is a rhombus, DC will be also 26 because all these four sides are congruent. This is a property. This is the definition, in fact, of a rhombus. Okay, let's go to part B. We need to find DB is this diagonal, right? And we notice that this part DT here, it's 10. So how much is going to be DB? DB is going to be twice DT because that is a property of a rhombus that comes from the fact that the rhombus is a parallelogram. So like I said, DB, it's twice dt because this diagonal AC bisect diagonals DB. So DT and TB are congruent. So we have here 2 times 10. So DB will be 20. Let's move to C and D, where we need to work with some angle. We need to find the measure of angles DBC. Okay, so let's see that angle DBC. It's this angle. You notice I marked the same with this angle, 70. Those two angles are congruent. Why? Because the diagonal in a rhombus bisect opposite angles. So this property works only for rhombus. Okay, and we have a last one, part D. We have to find the measure of angles TAB. Let's take a look. TAB is this angle. And for that reason, I'm going to find this angle. And you notice I mark them the same because these two angles are congruent. These diagonal AC bisect angle DAB and angle DCB. This is a property of the rhombus. But also, don't forget, this angle here is a right angle because the diagonals in a rhombus are perpendicular. So now, how can we find these angles? We're going to do 90 minus 70. And that will be 20. And in fact, let me be sure the math I did here is for angle BAT. Oh, that's the angle, you're right, we good. TAB. Yeah. Okay, so the measure of angles TAB is 20 degrees. Okay, let's go to the next example we have, and we have now again a rhombus. That is the meaning of this sign, and we need to answer to part A through to problem part A and part B. So let's take a look here. We have to find these angles 1, 2, 3, and 4. So how are we gonna do that? Remember, these two are congruent because it's a rhombus. That means these two angles are congruent. Okay, so yes, you can call that triangle an isosceles triangle. So the first math I'm gonna do it is 180 minus 106. That will be 74 degrees. And then I will divide this 74 by 2 because those angles, like I said, are congruent, and that will be 37 degrees. Measure of angle 1 is 37 degrees. Measure of angle 2 is 37 degrees. Why? Because these two angles are congruent. The diagonal bisect angle BAT. Measure of angle 3 will be 37 degrees for the same reason, and the measure of angle 4 will be 37 degrees. Let's take a look to part B, where we need to find also these angles 1, 2, and 3. The first one will be angle 1, which is congruent with this angle. Remember, these two sides are congruent, so we have in fact an isosceles triangle, and this is a property of the rhombus. So the measure of angle 1 is 26 degrees. Now, how do I find the measure of angle 2? I'm going to add these to 26 degrees. And that will be 52, right? Okay, this is the sum of the angle 1 and that angle that is marked 26. And how do I need to find what do I need to do to find, the measure of angle 2? Just subtract from 180 this 52. Why? Because the sum of the measure of the interior angle of triangle ABC is 180. So we have two of them, 26 and 26, which is 52. We're subtracting from 180. So we finish this. Angle 2 will be 128 degrees. We have one more angle to find out, angle 3, which is the same with angle 2. Opposite angle in a rhombus are congruent. This comes from the fact that a rhombus is a parallelogram. So the measure of angle 3 will be also 128 degrees. Okay. In the next example, more angles to be found, and also we need to find the length of BD on part B. So how do we find these angles? First of all, let's notice here we have this angle, it's 58 marked. Now, my next thing will be to mark this as a 90-degree angle. Why? The diagonal in the rhombus are perpendicular. So I'm gonna write here, because I want to be sure we remember this. AC is perpendicular. That's the meaning of this sign on BD. So the measure of angle 2 will be 90 degrees. Okay. What about angle 4? Now, angle 4, we can find it easy. This is a right triangle, triangle AED. So very simple. We can just simply, for angle 4, we can simply do what? 90 degrees minus the given angles 58 degrees, right? The angles in right triangles, the acute angle in the right triangles are complementary. So the measure of angle 4 will be 32 degrees. Measure of angle 1 will be the same with the measure of angle 4, because remember the diagonal in a rhombus bisect opposite angles. So measure of angle 1 will be also 32 degrees. And we have one more measure of angle 3. Measure of angle 3 will be the same with this angle. I remember a rhombus is a parallelogram, so these two angles are alternate interior angles. The sides of the rhombus are parallel. So measure of angle 3 is 58 degrees. Now we can go to part B. Part B, we need to find the length of BD. Okay, and if you notice, BD is this diagonal. So I have AD, it's 17, this is 17, and AE, which is half of diagonal AC, is 15. So we have a right triangle. If you remember, I marked this angle here. We have a right triangle. And we know this leg is 15, this is the hypotenuse is 17. How do we find this x? So you're going to use Pythagorean theorem, right? A squared plus b squared equals c squared. Be sure a and b are the legs. So we're going to have 15 squared plus x squared equal 17 squared. So let's grab a calculator and do 15 squared, which is 225. Plus x squared equals 17 squared is 289. So we have here x squared equals 64 if we subtract 225 from each side. So x will be square root of 64, and since this is geometry, we don't need plus and minus, just the positive one. So x equals 8. Remember, the x means ED, right? So ED is 8. We have one more step to find BD. BD will be 2 times ED, twice ED, will be 2 times 8. So BD will be 18. And that's it for this problem. In some cases, you have to use your algebraic skills for solving problems. Like in this case, we have the measure of angles DAC. This gentleman here, it's 4x plus 9. And the measure of angles DAB, this big angle, I'm going to mark it different. It's 11x minus 3. What is the relationship between these two angles? First of all, I'm going to mark this angle here the same like this one. So I hope that will help you to see that 2 times the measure of angles DAC is the angle DAB, the measure of angles DAB. Yeah, if we add these two angles, we get the big angles, and these two angles are the same. So that's the reason we can write this statement like this. So we have 2 times the quantity 4x plus 9 equals 11x minus 3. So we're going to do distributive property here, and we have 8x plus 18 equals 11x minus 3. And from here you can solve it in a different way. I'm going to subtract 8x. And I have here 18 equals 3x minus 3. We're going to add 3 on each side. We're going to get rid of this minus 3, right? And have 21 equals 3x. And divide by 3. X equals 6. Now, we are not done with this problem because we need to find the measure of angle ABC, which is this angle here. Okay, this angle is supplementary with this angle. So let's find the measure of angles DAB. That will be 11 times 6 minus 3. So that will be 66 minus 3. That will be 63 degrees. And like I said, angle ABC is supplementary with the angle DAB. So that's the reason I'm going to say the angle ABC, the measure of angle ABC is 180 minus the measure of angle DAB. So that will be 180 minus 63, and that will be 117 degrees. That is the measure of angle ABC. Okay. Next problem, very similar. We just have to set up an equation that will say, hey, these two angles you see here are congruent, because that is the property of a rhombus. So angle BAC congruent with angle BCA. The diagonal bisect opposite angles. So in fact also these two angles are congruent in fact. And that means they have the same measure, which in our case means we replace these measures of these angles of the expression, which are what? 7x squared minus 10 equals 6x squared minus 3x. So we have a quadratic equation here. We need to set up this one to 0 to have the standard form, how it's called. I think the best way is to subtract 6x squared. So we have here x squared. I'm going to add also 3x because I want to have 0 on right side in this case. So we have x squared plus 3x minus 10 equals 0. We have a quadratic, and I will solve this one by factoring, and the factor form will be x minus, in fact, x plus 5 times x minus 2 equals 0, which by setting up each factor of 0, x plus 5 equals 0, we have x equals negative 5, and x minus 2 equals 0, we get x equals 2. Now, it's very important to check, maybe not both of them are good value in our case. So how am I going to do that? I will take this each value and plug it in, and I'm going to do that here. 7 times negative 5 squared minus 10. That will be 7 times 25 minus 10. And 7 times 25, that will be 151, 75 minus 10, and that will be 165. Okay, so is it possible to have an angle like this, 165 plus another 165? That doesn't really work, right? So I will say from geometrical point of view, this solution is not okay. But let's take a look to these two. So I'm gonna do 7 times 2 square minus 10, and 7 times 4 minus 10, that will be 28 minus 10, and that will be 18. I think this one makes sense. This 18 does make sense for this geometry problem. So this is the value of x. Sometimes you're gonna have to work with figures in the rectangular grid. My first thing will be to plot if that is possible. And in this case, I will suggest you to grab some graph paper and plot these 4 points, A, B, C, and D. I did it right here. It helps, right? We see A is -7 and -1, B is -2 and 1, C is 1 and 5, and D is -4 and 5. Yeah, that works fine, and it looks like a rhombus, but we need to prove it, right? So first of all, how do we prove this is a rhombus? So we're gonna take a look to the slope of the sides. That is one way, by the way. So we look into the slope of AB, and if you notice, AB is a horizontal line, the slope will be 0. DC the same thing, be 0. So just these two statements here tells us that AB and BC, these two segments, AB and DC, I'm sorry, are parallel segments. Let's take a look now to the slope of AD. The slope of AD, if you take a look, we have 1, 2, 3, 4, 1, 2, 3. We have a rise of 4, a run of 3. It goes up from left to right, so it's positive 4/3. If we take a look to the slope of BC, we have the same situation, 4/3. So yes, we know now, we justify our answer, at least the first part, that AD is parallel with BC. From these two statements, we can say A, B, C, D is a parallelogram. We cannot say a rhombus, yet. What else we need to do to prove that this is a rhombus? We need to prove that two sides are congruent. So now let's take a look. AB, it's easy to be found. 1, 2, 3, 4, 5. That will be 5. So now we need to look to either AD or BC. Okay. Don't look to DC. DC, in fact, is 5, but that doesn't help us. We need to have these two consecutive sides congruent. So for finding AD, again, I'm going to use this triangle, which I use it for finding the slope. This is 3, this is 4. So in that triangle, AD and let's say E, we can use, this is a right angle, Pythagorean theorem, we can say A squared plus B squared equals C squared. And now we have 3 squared plus 4 squared equals that AD, which I'm going to call it X, AD squared. So we have 9 plus 16 equals X squared. 25 equals X squared, and for finding X we need to take square root, and square root of 25 is 5. But don't forget, X is nothing else than AD. So now we know these two sides are congruent, they have the same measure. We know ABCD is a parallelogram. So now we can say the final statement, which is yes, A, B, C, D is a rhombus. So why this is a rhombus? First of all, it's a parallelogram. We prove it, and then it's a parallelogram that has two consecutive congruent sides. These one are also going to be the same. All sides are congruent. So this is a rhombus. In my last part of the lesson, we're gonna take a look to some proofs, and let's take a look to this one, which says write a proof. So we can choose a 2-column proof or a flowchart, and we know this ABCD is a rhombus. All sides are congruent. We need to prove that AC is perpendicular on BD. We need to prove this is a right angle, for example. Okay, so now what else we know? We know if this is a rhombus, is a parallelogram, so these two guys are going to be congruent because the diagonal bisect each other. So I'm gonna start with the fact that this is a rhombus. Okay, and I'm gonna do a flow chart, and this is given. From this statement, what can we say? We can say a couple things. First of all, we can say all the sides are congruent. AD congruent to AB. We're gonna use that. Also, you can say congruent to DC, congruent to BC. Okay, and also we can say the diagonals bisect each other. And here I'm just going to use only the fact that DE congruent to EB. And you know what? We can write the other one. Also, AE congruent to EC. And I should have some space there. Okay, let's be sure we have some spares. Let's put the reason here. The reason is simply ABCD is a rhombus. And this is a property of the rhombus. Then, like I said, let me go down here. DE, like I said, is congruent with EB, and also AE is congruent to EC. And well, what's the reason for this property? Diagonal bisect each other. Okay, but now also we have this as a common side. Now let me erase this right angle here, because that is what we need to prove, right? We're gonna write only what we can do, what we can prove, we can assume. And now we have A is congruent with itself. And if you remember, the reason for this is reflexive property. And now from these three statements, we can write what? We can write that triangle ADE is congruent with triangle ABE. And this will be nothing else than side, side, side criterion for triangle congruence. And now from this gentleman here, we can say these two angles needs to be congruent. So angle DEA congruent with angle BEA, and here we'll say corresponding parts of congruent triangles are congruent, well, which allows us to say another thing, that they have the same measure. And let me do that here, because I don't know if I'm going to have enough space. That the measure of angles DEA plus the measure, I'm sorry, I kind of thinking to the next step. The measure of angles DEA equals with the measure of angle BEA. That's his definition of congruent angles. But also, what about these two angles here that are congruent? They are also form a line, they are supplementary. So I'm going to say here the measure of angles DEA plus the measure of angles BEA equals 180, and I'm going to put as a reason linear pair. And now we can do a substitution from these two statements. And we can say, for example, we can take this angle DA and replace it here. And we have twice the measure of angle DEA equals 180. Substitution, property of equality. So basically now we know the measure of angles DEA is 90 degrees, because we divide by 2, right? Division property. One more step and we finish. Now we can say AC is perpendicular on BD, because this is the definition of perpendicular line, right? They form a 90-degree angle. Well, this is a nice flow chart for proving one of the property of the rhombus. Remember, the rhombus has this property, the diagonal bisect each other, and this is a way to prove that property. Okay? Let's go to the last one. Yeah, the last theorem, and in this one we're going to prove another property of a rhombus, which is that the fact that the diagonal bisect opposite angles. So that's what I said here. So again, what is given to us is these ABCDs are rhombus. So we know all these sides are congruent. But also, very similar to what we did in the previous one, we know these two are congruent because the diagonal bisect each other and these two are congruent. So very similar, you see, we go towards the same kind of proof. We're going to prove triangles are congruent, so then we're going to have a bunch of angles congruent, like this angle and this angle, this angle and this angle and this angle. Okay, so that's the goal. That's going to be the thing. So that's my goal on this flow chart. And again, I'm going to use a flow chart. So I'm going to start with what is given: A, B, C, D. Rhombus is a rhombus, right? And that is given. Then my next thing will be to say all the sides are congruent, like in the previous proof, AB congruent with BC congruent with DC congruent with AD. And what's the reason here? Property of a rhombus, or you can say ABCD is a rhombus. Property of rhombus. Okay, but also based on this guy, we can write, like I said, another statement, which is two statements, in fact. AE congruent to EC and also I can write, and maybe I'm gonna need that also, DE congruent to BE. Let me write the reason first. For the other one, diagonal bisect each other. Okay, and now I'm gonna write the next statement, very similar, DE congruent with EB. And the same reason. And I'm not so sure if I did the right organization here. I did the right thing, but the way I organized, diagonal bisect. Okay, but now, like I said, we're gonna take 2 by 2 triangles, and I'm gonna start to AE congruent to V itself. And if you remember, that is the reflexive property. Now, from this statement, AE from this one and this one, from this statement we can write what we did before, triangle AED congruent to triangle AEB. And if you remember, the reason was side, side, side is the same. Now side, side, side postulate. But also, let me change the color and go in with a parallel thing. So from this statement, from this, and one more, which is EC congruent to itself, EC. And will be reflexive property, right? Okay, we're gonna have two more triangles congruent, which are the triangle DEC congruent with triangle BEC. Side, side, side. And now let me go back to the first two triangles. From this one, we're gonna say, right, now we can say these two angles are congruent. Angle DAE congruent with angle BAE. here is going to be corresponding parts of congruent triangles are congruent. And from this second statement involving triangles, we're going to write very similar. These two angles are congruent. Now you may say, we don't know if they are the same, and that is correct. But let me write this statement first. Angle DCE congruent to angle BCE. And the reason for these two triangles being congruent is the same like in the previous statement. Corresponding parts of congruent triangles are congruent. Okay, now, like I said, some of you may say, hey, these two angles are different than the other one. Now you can prove it that these angles are congruent because this is an isosceles triangle. But in fact, we don't really need that, because bisect BAD and DCB is right here. Yeah, by having these two statements, we can say yes, AC bisects angle BAD and angle DCB. And what will be the reason for this statement? Definition of angle bisector. Remember, the definition of angle bisector says it cuts the angle in half, and which we see here. These two angles are congruent and these two angles are congruent. Yes, AC cuts the big angle in half. And that's it for this long and interesting proof. And I wish I could organize in a better way, but it is what it is. If you enjoyed this lesson, don't forget to click the like button and come back and see square for more help. Thank you.